Every Who down in Huluville liked the holidays a ton, but where to get great prices on gifts, they had no idea. None. They searched and they searched for great gifts under $25. Gifts for spouses and friends and even their toddlers. When suddenly one Who shouted, Walmart has what you want, knowing they have Lego, Tree Hut, and low prices to flaunt. So they enjoy the holiday season as Who's often do, cheering and shouting, Walmart has incredible gifts. Who knew? Find gifts they'll love under $25 at Walmart.
'Tis the season for all your holiday favorites, like A Very Jonas Christmas Movie and Home Alone on Disney+.
Should I burn down the joint? I don't think so.
Then Hulu has National Lampoon's Christmas Vacation.
We're all in for a very big Christmas treat.
All of these and more streaming this holiday season. And right now, save big with our special Black Friday offer. Bundle Disney Plus and Hulu for just $4.99 a month for 1 year. Savings compared to current regular monthly price. Ends 12/1. Offer for ad-supported Disney Plus Hulu bundle only. Then $12.99 a month or then current regular monthly price. 18 plus terms apply.
We live on a fantastic, glorious planet. But on this planet, we're looking out at the heavens. And in this Christmas lecture, we are going to travel out there, understand it better, and search for life out there. And so if you have ever asked the question, are we alone in the universe? Come and watch.
Dame Dr Maggie Aderin-Pocock is an immensely accomplished space scientist, science communicator and educator who is taking centre stage this December as the bicentennial Christmas lecturer from the Royal Institution, supported by CGI. From working on the revolutionary James Webb Space Telescope, presenting BBC Sky at night, to being elected as the Chancellor of the University of Leicester, and even having her very own Barbie doll, Maggie has been paving the way for the next generation of space scientists for decades. I sat down with her on the morning of the Youth Summit for the Christmas lectures to chat about the fascinating space science she's been a part of in her career so far, and a sneak peek into what might be in store for the lectures. Maggie Aderin-Pocock, the Discover 200 Christmas lecturer. Thank you for coming on the podcast. Welcome.
Oh, lovely to be here.
I wanted to start with something that the Christmas lectures have been pioneering throughout these 200 years, which are, of course, the demonstrations, or demos, as we like to call them with our RI slang, which I'm sure you got to know very quickly. So they're all thanks to our incredible demo team, who have actually just won the 2025 Hawksby Award from the Royal Society, which is very exciting.
Fantastic, yes.
But making science visual and theatrical requires a lot of thinking outside of the box, which is something that we really love to do here, and we maybe don't see in standard science education that much. You've spoken a lot about your experience with dyslexia, and you've said before that dyslexia helps you to not just think outside the box, but think outside the planet. So how have you found that creativity has helped you in science?
So it's funny because one of my bugbears is that people think, oh yes, the arts are creative and science is sort of factual and logical, and it's totally untrue. I mean, there's overlap in both of them, and I love creativity in science. And so my degree is physics, my PhD is mechanical engineering. And so I'm a sort of a hybrid. I'm a scientist and an engineer. Mm-hmm. And to find creative solutions to the problems and challenges we face on Earth, it needs creativity. It needs sort of not just doing things the same old, but thinking of new ways to do it and exploring new things. And so, yes, as a space scientist or building satellites that sort of go up in space, it is trying to find solutions. You're in low Earth orbit, 400 kilometers above sea level, and you're trying to look at the minute details of maybe microplastics in the ocean. Now, that's a lovely example. A few years ago, people were trying to sort of monitor microplastics from space, but the resolution of microplastics, they're tiny. Yeah. So how are we going to see them from space? But someone noticed that where the microplastics gather in sort of large sort of conurbations, the waves are different, and you can measure waves from space. And so people were able to say, okay, we can work out where the microplastics are by looking at the waves, seeing where they are different and working out that they're there. Not only that, you were able to sort of retrospectively look at previous data gathered and work out the migration of the microplastics. So it is just thinking differently. And that creativity is so powerful. But to me, it's powerful in whatever we do.
Yeah, and I think it's bringing all those people with different viewpoints together as well, because they bring their different perspectives. And we do that a lot here, where everything's a very collaborative process. So
I love that.
Yeah.
Because we, and actually my career has been a sort of testimony to that. Because I've sort of worked for the MOD on missile warning systems and landmine detection. I've worked as a science communicator. I've worked on satellites, and all these different aspects bring different knowledge. And when we work together and bring different people, diversity, it just makes it a joy to do the work as well.
the science of worlds beyond our own and space has been piquing people's interests for a long time. And it's not just people who are interested in science that love space. Everyone seems to have a big interest in space. And you're joining a big list of scientists to give Christmas lectures about space, starting with John Wallace in 1838 with the first space Christmas lectures, to Carl Sagan in the 70s, and most recently Kevin Fong in 2015. Why do you think people find space so interesting?
I think space is one of those things that it sort of it makes, I always say, it makes my heart sing.
Yeah.
And I think I like to sort of go back in time. I think it's something fundamental in all of us. If you go back far enough, I like to think of a time where people didn't actually even speak or communicate in words. And I always say that space was sort of the Netflix of the early humans.
The original Netflix.
Yes,
I like that.
Because every night, by the campfire, looking up,
it's like an analog Netflix.
It is.
Yeah.
And so, but then people came up with sort of creation stories and myths because it is just so visual, and so it catches the imagination, and people want to understand, what is this we're seeing? What is this? And so through science, through engineering, we have explored it and sort of come up with initially creation myths, and then sort of astrology. So, yes, it's influencing us on Earth. And then we started with technology. So, how can we get a closer look at it with telescopes and sort of satellites and probes that actually land on other planets? So it's been a long, drawn-out process. But I think it is that curiosity and that creativity to find out what's out there. And I think it draws us in. I think it's one of the things we might be losing, because we live in a world which is 24 hours, street lights and things like that. And I think we need to take the time out to just step away and look up. And for me, I live a manic life. It's just in my nature. But for me, it is sort of stepping away and getting a sort of a fairly clear bit of sky and looking at the stars or seeing the moon. I always say the moon for mindfulness, because it just calms me down. And I think we need more of that. But we're harking back to our ancestors.
I remember seeing a quote in a book that I read that said humans, or Homo sapiens, were the first species to look inside their mind and see the whole cosmos reflected inside. And I always loved that quote. I think I maybe put it in my personal statement or something when I was applying for university. So it really stuck with me. But yes. I think it made me realise that it's also the fact that as humans we've taken that step that nothing else has, to kind of look beyond.
Yes.
Which is crazy.
I do love that. It's a beautiful quote.
Yeah. Because
it was like the cosmos reflected in us, and I think that's why we are drawn to it, maybe. But I do love the idea as well. I think sometimes we underestimate our fellow creatures on Earth. Mm-hmm. I can imagine actually lots of creatures are sort of influenced by the moon and the stars instead, in terms of spawning and things like that. So maybe others are contemplating too.
Yeah, maybe they've seen a bit of it reflected as well. We can't understand.
That's it. We just don't know.
And language is a whole other question. So we won't go into that. But so talking a bit more about your journey into space and how you found it interesting. You've told a story before about when you realised your scientific interest and your kind of aptitude for it as well, where you could determine the weight of a cubic centimetre of water really easily, and you were kind of thinking, how can other people not figure this out as easily as I can? So how did you get from the cubic centimetre of water to space science? How did you get to that interest once you realised science was kind of what was really working for you?
So as a dyslexic, I wasn't diagnosed with dyslexia. In fact, I only had my formal dyslexia assessment in sort of about 3 or 4 months ago.
Oh wow, really?
So, yes.
Very fresh then.
My daughter kept saying, "Don't do it. What if you're not dyslexic?" But fortunately, I am. Oh. So I didn't know I was dyslexic when I was at school, and so and especially when you start at school, it's all about reading and writing, and those things I find really hard as a dyslexic, but I loved storytelling. With dyslexia, it's definitely a yin and a yang. There were some things that sort of like storytelling and logic. And I remember sitting in the class and the teacher asking the question and me being able to work it out and putting my hand up for the first time and then realising no one else had their hand up. So I'm the dumb one, what am I doing? But I think space was always there right from the get-go. I was born in 1968. 1969, the moon landings happened. And so I didn't remember the moon landings. I was too young, but I was caught up in that excitement. And then I started watching the Clangers.
Real throwback.
Little pink creatures that live out in space. And I fell in love with those. Decided I want to go and visit. I got a chance, actually. I'll tell you about that later.
Oh, yes, please do.
Yes. And so space was very much a part of my upbringing. Star Trek as well, always part. And so I was fascinated by space and I wanted to get out into space. But I wasn't too sure how to go about it. And then when I realised that it's science and engineers that get people into space, that seemed like a natural sort of way to go. And with the dyslexia, the logic, the curiosity, the exploration all came in as well. And so science seemed to be the way to go. Now, of course, at this stage, I was at the back of the class, as I like to say, with the safety scissors and the glue. So becoming a space scientist seemed like a mad idea. But I think I like to encourage kids to have mad ideas, because when you do, it means that you find ways and you look for opportunities to get closer to your mad almost obsession.
Well, it's like you said, talking about it makes your heart sing. And I think finding that thing that does that for you, and that can often take science being a little bit more creative or us blowing something up, which we do a lot, and things like that. So I think that can help to find that passion, which is really important to follow.
But I think it's just what you say. Here at the Royal Institution, it's sort of the demos and the bangs and the things, there's the science behind it, so we know what's going on. But it's also that sort of, that capturing the imaginations. And as a space scientist, I love to do that. But as a science communicator, it is finding those hooks. What makes the kids say, I want to find out more? And as a child, I had those hooks. And so passing those hooks on, through the fantastic demo team here, and so the Christmas lecture is just a wonderful opportunity to explore that and work out what we can blow up.
Do you have any specific demos that you'd really love to do? Do you have any kind of bucket list demos that you really want to make sure we can work into the lectures?
There's been a few, and I sort of put them out there and guys,
can we please find a way to make this work?
So one of the things I mentioned, I love the moon. I call myself a lunatic. Self-certified lunatic. Self-certified is very important. But so talking about how the moon has influenced Earth, I think is very important. And the moon was formed when a planet the size of Mars collided with the early Earth. And there was this cataclysmic collision. And then the detritus sort of formed the moon. And so sort of trying to recreate something like that, I think would be fantastic.
I think if anyone can handle it,
it's the demo team here.
Yeah, it's the RI. So when this episode comes out, it will just be a couple of weeks until we're filming the lectures. So by then, hopefully, we might be about to do that.
Yeah,
so
will it be in the...
Stay tuned, because it might be happening.
A crazy dream, but as I say, crazy dreams can come true.
Yeah, exactly. So watch this space, because we might be recreating the moon. On top of being the 200th anniversary Christmas lecturer, which is, I guess, a big enough deal in its own right, you'll also be the first woman of colour to present the lectures, which I think is equally as significant as that in a different way. So I guess this is similar to your experiences with dyslexia as well, but how do you think the experiences of young girls of colour hoping to get into science now are different than when you were growing up, if they are? And how do you think that kind of impacted your journey as well?
So I think there is an adage, you need to see it to be it. And when I was growing up, I didn't see Black female scientists. And it's quite interesting because there's this video made by, I think, Teachers TV, and it's talking about sort of girls not wanting to do physics. Yeah. And you sort of, they were showing the school that these girls were in, and they showed you sort of the great and the good of science on the walls. So they had, sort of Isaac Newton, they had Stephen Hawking, they had Professor Beaker from the Muppets, but they didn't have one woman on the wall. And the things, there have been some fantastic women in science, but we need to celebrate them and celebrate their work. And I think I was just dogged-minded. I wanted to be a scientist by hook or by crook because of my crazy dream. But other people think, oh, well, if women don't do science, I've seen no evidence for women doing science. And so the thing is, I meet fantastic women scientists from different ethnic minorities, all working and collaborating together. And so it's getting that message out there. To be a scientist, you just need to have that curiosity, that drive, that wanting to explore. And we welcome people from different religions, from different races, because it makes science stronger. And so getting that message, I think we're working on it. I don't think it was very much around when I was a child. I think it's getting better. And that's one of the reasons I love doing sort of lectures and going out to schools. I think I've seen 600,000 people in the last 20 years.
Wow.
So I'm knackered, but it's been brilliant.
Yeah, that's intense.
Yes. And it's just sort of saying, I'm a space scientist. I love what I do. What do you love and what can you do? And how can it help humanity? And I think kids respond well to that, knowing that they can make a difference.
Yeah, and I think like we were saying earlier with people with different types of creativity, having people from different backgrounds brings different perspectives, and you can have someone who might clock something that someone else hasn't clocked before because they've had a different experience. So it's for the good of science as well. It's not just for the good of it being an important thing to do.
Yeah, we're not doing it because it's the right thing to do.
Yeah.
It is the right thing to do.
It is, but
also
also
it goes way beyond that.
Science benefits from it, and it's the same for everything as well, not just science.
Yeah, but the individual benefits too. There's something called Ikigai, which I like to. I go to my daughter's school sometimes, and I do career speed dating, which sounds really weird.
Yeah.
What it involves is I have a year group, so maybe 180 kids, and I get to speak to each student for about 3 minutes. And you think 3 minutes, how can you give career advice in that time?
Yeah.
And so I mentioned this thing called Ikigai, and it's a Venn diagram of 4 circles. And it's the Japanese art of life fulfillment. And it's sort of, I always get it wrong. Yes, what you're good at, what the world needs, what you can get paid for, and what you have a passion for, I think. No, what you're good. Anyway, it's these 4 circles. And if you get work right in the middle of those 4 where they all overlap, you have Ikigai, you have life fulfillment. And that's what I'm encouraging. When I go out and speak to kids, I know that not all of them want to be scientists. That's fine. But find what makes their heart sing. We spend too much time at work not to find what we're passionate about and work in it. And so that's what I like to encourage. Crazy dreams, reaching for the stars, and finding what makes your heart sing.
So on Crazy Dreams, you mentioned something with the clangers. Let's unpack that story. Let's get into it.
Yes. So as a child, I mentioned that I loved the clangers, and the clangers actually we're almost similar age to the clangers, and they celebrated their 50th anniversary a few years ago. So the clangers were around when I was a child, and then they sort of went away, and then they got rebooted. And when they got rebooted and they were on CBeebies, they contacted me. And they said, you've mentioned that, you became a space scientist partly because of the clangers. Would you like to be in an episode? And it was, ooh.
That, you've made it. You've made it.
Well, I'm only the second human to have visited the clangers.
Who was the first?
Oh, see, unnamed, but he had a big bushy moustache and he went to visit the clangers.
Interesting.
in the previous sort of series. And then sort of I got to go back, and we went to Altrincham where they make the clangers, and I met the woman who knits them.
Wow.
And I held the soup dragon in my hand, and there were tears streaming down my face.
That's amazing.
And my daughter was saying, Mum, it's a puppy.
Oh, you don't understand.
This is a dream
come true. That's why you need to put your dreams out there, because
Yes.
someone might be listening and it might happen.
Yeah. So anyone listening who can get me into space,
Yeah.
Maggie, looking forward to it.
Well, yeah, follow your dreams purely because you might get to meet the clangers. I think that's a good enough reason. Looking back over the past 200 years of Christmas lectures serves as quite a nice time capsule of how scientific knowledge has changed over time. Definitely for space, that works really nicely. And a big part of space that is a really good example of this is capturing images of space and how that's changed over time. Because back in the 1830s, photography was only really finding its feet, was barely really a thing. Then around the time of Malcolm Longaire's space lectures in the 90s, the Hubble telescope was launched, I think the same year as those lectures. And of course, we now have the James Webb Space Telescope, JWST. So looking at those two, the Hubble was a really huge pivotal moment for space imaging. And then so was JWST. So how are they different, and what has the JWST kind of built on from the Hubble that it wasn't able to do before?
Yes. So, I worked on JWST for many years. And when it was first sort of postulated, it was called the Next Generation Space Telescope.
Oh, catchy.
I know. I thought, wow, it has really Star Trek-y. It's brilliant. But then after a while, NASA said, no, it's going to be called the James Webb Space Telescope. And everybody said, who the heck is James Webb?
James Webb.
He turned out to be the second administrator of NASA who actually helped get the Apollo moon landings. So we can understand.
That's fair.
Yes. But it is that sort of evolution that we from our viewpoint on planet Earth, we look at in space. And first of all, mark one eyeball, just checking out what's out there, trying to understand. And then photography comes along, and not only can people draw what they see, but they can capture and share what they can see. And that's quite powerful. I'll throw in there a bit of the telescope as well. Telescope, we can see things that are far away in much more detail. So there's sort of these, as you say, these evolutions. And so, yes, the Hubble Space Telescope was groundbreaking. Still embarrassing that when it was first launched, the mirror wasn't quite the right shape. But we had to, actually, many people have forgotten this, but when Hubble was launched, the mirror was actually made to the wrong specification. It was given the specification it was given, but it was the wrong one. And so when it went up into space, the images were almost as fuzzy as they were on Earth. But it was fine. It's creativity.
Yeah.
They designed glasses for Hubble.
Oh.
And they went up on the space shuttle and fitted these glasses on Hubble, so Hubble could get the detail that we wanted. And so Hubble's been out there for 30 years, and it has been exploring the universe, mainly working in visible light. As a space scientist, I like to say I trip the light fantastic. So many of the instruments I've worked on, especially on ground base, have been optical, so visible, looking at the rainbow colours of space and interpreting that down here on Earth. But Hubble went up in space. It was looking at visible light, but sort of sneaking into the infrared, so heat energy, and also into the UV, getting information about that. But the thing is, there are parts of the universe where visible light won't penetrate. And so if you've got a telescope, you won't pick up those bits of light, those bits of the electromagnetic spectrum. And also there are parts of the electromagnetic spectrum that won't penetrate through the Earth's atmosphere. So putting a telescope up in space, you're up above the atmosphere, so you're much less turbulent, but you can also pick up these different parts. Now, the James Webb Space Telescope isn't a visible telescope, it's an infrared telescope. So it picks up that heat energy. And as a result, it sits 1.5 million kilometers away from planet Earth. And it's actually directed, pointing away from Earth and away from the sun, because if it looked at those, they would be dazzled by the amount of infrared coming from both of those bodies and lots of other things. So it looks into deep, dark space. And so it's able to sort of collect light that we can't do from the Earth's surface. And it's also, as the universe is expanding, so since the Big Bang, we believe the universe is expanding, visible light gets stretched into infrared light. So it gives us the ability to look at the early universe. We'll look at how the first galaxies formed, how the first stars formed. And so it gives us a snapshot back in time as well. And so it's sort of a changing. Hubble was amazing, and it really set our understanding of the universe. But as well as with many of these missions, it answers many questions, but it throws up a whole lot more. And the James Webb Telescope was designed to actually answer some of these other questions. So that's what JWST is doing. Hubble posed a question, and JWST is able to look in more detail and get sort of the right sort of light to perhaps answer some of these questions. But in itself, JWST is throwing up more questions. Like galaxies, if you look at the early galaxies, they seem to be bigger than we anticipated. They seem to form faster than they anticipated. So why is that? And what does it mean for science?
Well, I'm sure the next Space Christmas lectures will probably be sat asking these equivalent questions about JWST and whatever the next big telescope is called. Maybe the next generation telescope, or whoever gets to put their name on it.
But it is wonderful, because I think it was Sir Isaac Newton that said we are standing on the shoulders of giants. And yes, and so we are doing that as humans in terms of our knowledge, but in instrumentation as well. You build an instrument, we look out in space, we gather knowledge, and then it throws up more questions. So we build the next generation and try and answer some of those questions. It makes it exciting. and just part of. And also, we're studying the universe. We're never going to run out of things to study.
No, I don't think that's a risk. So you were one of, I think, 10,000 scientists who were working on JWST. What was that experience like, and what specifically was the work you were doing on it?
Yes. And so I always like to say, because I worked on JWST, but it's nice to put it into perspective. One of 10,000 scientists. I know. Yeah. So there were a few of us.
Yeah.
And JWST is, there's the telescope itself, so the telescope mirror, but with all telescopes, ground-based and space telescopes, it's the instrumentation that does sort of the grunt work. And so the telescope gathers the light, but then you have a number of instruments which actually takes that light and analyzes it. And on JWST, there's some fantastic things like the micro shutter array, which is a sort of like a shutter, but it's made out of thousands upon thousands of tiny little windows, sort of smaller than a human hair. And it means that when we're looking out in space, you can say, okay, I want to look at that star, and that star. So you open the appropriate shutters, get that starlight and analyze it. And you can analyze it just by taking a photograph, but you can do spectroscopy. And spectroscopy is my bread and butter. And so I've made spectrographs for ground-based telescopes, but also space telescopes. And I was working on a spectrograph called NIRSpec, the Near Infrared Spectrograph. And the joy of a spectrograph is what it does is it takes the light that you gather from a distant star or object, and then what it does is it stretches it into its component wavelengths. So if you're looking at visible light, it will stretch it into its rainbow colours. If you're looking at infrared, we actually sort of stretch those different wavelengths out. And then you get a sort of a distribution. You've got more of this wavelength than this wavelength. And that tells you all sorts of things about the object you're looking at. That's how we discovered the universe was expanding. By doing spectroscopy, we realized that everything is red shifted. So everything has their wavelengths shifted, virtually everything has the wavelengths shifted towards the red, and that showed us that everything is moving away from us. So the universe is expanding. So spectroscopy is a wonderful workhorse, and you can do it in sort of visible light, infrared, sort of across the electromagnetic spectrum. And so yes, and that's what I was working at on the NIRSpec instrument, but making a subcomponent for the NIRSpec instrument. So you can take sort of an object like a galaxy, and then rather than just looking at like a blob of light, you can slice it up and look at what's happening at the center of the galaxy, what's looking at the outer edges of the galaxy. So do sort of remote chemistry of a galaxy trillions and trillions of kilometers away, but right here right here on a sort of James Webb Space Telescope, and then beaming the data back to Earth.
I remember when the first images got publicised of JWST, and this is such an RI thing, but I remember us all sitting in the office and kind of going through them and picking our favourite image. Oh, which one's your favourite image? I really like the purple on this one.
Yes. Although I have a confession.
Okay.
Yes, because
this is a safe space, you can say.
Because James Webb Space Telescope, JWST, is an infrared telescope, what we're picking up is infrared light, which we can't actually detect with our eyes. And so that lovely purple isn't actually purple, it's just been converted. So I know
it's a shame.
But with Hubble, you're actually seeing what Hubble sees, because it's visible light. But with James Webb, it's a visible interpretation. Still glorious, though.
Well, yeah, and I think the pros that you're getting from the learnings from it means you can sacrifice it being real purple. I think that's, we'll allow that.
Synthetic purple.
Yeah, that's fine. But you've obviously written a book on looking at the imagery. It's a bit of book promo there for you. Webb's Universe. It's very good.
Actually, Mark 2 is coming out too as well.
That's very exciting. Okay, you heard it here first. But did you have a kind of favourite image that came out of it, or even just a favourite learning from it so far?
I think there is a favourite image, and I think it's called the Pillars of Creation. And we were talking about sort of the historical sort of development of sort of looking out there into space, Mach 1 eyeball, and then sort of photographic plates. I think the first images of the Pillars of Creation were taken on a photographic plate in the 1920s, and I've seen it, and it's grainy and black and white, but you can see sort of the prominences. So there are three jutting pillars as part of a nebula. And if there's 3 of them, and if the top of one of the pillars is larger than our solar system. So they are vast. And this is, these nebula are where sort of a stellar, they're stellar nurseries. So where new stars are born. And so we've got this image in black and white from sort of the 1920s. And then when Hubble went out, it was one of the things it captured. And again, it was the sort of one of my favourites just because the colours. There was sort of, you can see sort of greens and oranges and blues. And it's sort of get an understanding where, up in this pillar at the top there, that's where sort of star formation is happening. And it's a different colour because, the radiation is being sort of released. So we saw it like that. And then JWST went and took an image of it as well. And now we're looking at it in infrared. And so it's this sort of evolution of knowledge. And also, I love that. I like saying tripping the light fantastic because you can look at it in the visible, you can look at it in the infrared, and you get different images. And from those interpretations and the differences, you can say, oh, yes, this is happening here and this is happening here. And so, yes, it's sort of like a timeline of our knowledge. And as you say, what's the next giant telescope going to be? And what will it reveal? But coming out and looking back at old favourites, so it will give us a new viewpoint of the pillars of creation. So, yes, that's one of my favourites.
Purina believes no one should have to make the impossible choice between their own safety and their pets. But nearly half of domestic abuse survivors delay leaving because they can't bring their pets with them. Through the Purple Leash Project, Purina is helping create more pet-friendly domestic violence shelters so survivors and their pets can escape and heal together. Visit purina.com/purple to learn more.
Hello, I'm Diane Morgan. If you know who I am, you know who I am. If you don't, who cares? I'm here to explain Italian Time, a holiday phenomenon where Italians throw away their clocks and gather for eternity with San Pellegrino. I've been at this party so long that I've eaten 5 courses, hugged someone's grandma twice and been offered a job in the family restaurant. So this holiday season, make sure to bring enough San Pellegrino to last you through the meal, the after meal and the entire goodbye ritual. San Pellegrino, holiday on Italian Time.
So one question that hasn't been answered in space science yet is the existence of extraterrestrial life. It's a big buzzy question. I'm sure you get questions about that all the time. And it's something that I would put money on that being mentioned in every space Christmas lectures over the past 200 years.
Yes.
And probably in the next 200 years of them as well. How close are we to having some kind of answer to that question?
There's evidence and then there's probability. Looking at the probability first, there's a wonderful thing called the Drake equation, proposed by a scientist called Frank Drake. I think he posed it in sort of the 1960s, and it was it's like a guesstimate of the probability of finding a sort of intelligent life or civilized life within our galaxy. And it has lots of terms like, the rate of star formation, how many of those stars have planets, and various other things. One of my favourites is how long does a civilization last? Because if there is a civilization out there, I always like to say that they came at the time of the dinosaurs, looked around, thought, don't like the look of this, and scarpered. Yes. So our civilizations need to overlap. And so, but looking at the probability, when Frank first sort of postulated the equation, there was lots of unknowns. Like we were suggesting that there might be exoplanets, planets going around the distant stars, but we hadn't seen any evidence of them. Now we have that. We found 6,000. With JWST, we hope to find many more. So, we're building up this knowledge. But if you just look at sort of our galaxy contains approximately 300 billion stars. And each one of those stars is a sun like our sun. And we're detecting the planets going around those stars. So we know that there are many planets out there. Another thing that has happened is that we've found life on Earth where we didn't think it was possible, in the deep, dark oceans of planet Earth, like the places like the Mariana Trench, which means some of the moons in our solar system and maybe the moons in these sort of extra solar systems, they might have life as well. So just within our galaxy, 300 billion stars, we think maybe each star on average might have 1 or 2 planets. That's a lot of planets to choose from. But we were talking about sort of how Hubble was a game changer. The Hubble Space Telescope helped us realise that in the whole of the universe, there are about 200 billion galaxies, give or take a few. And so to me, it's a numbers game. Why would life just occur here? And also, as humans, we're very conceited. We always think we're the center of everything.
Yeah.
I mean, it started off, Earth is the center of everything. Oh no, it's the sun. And then the sun is now part of, 300 billion galaxies. So I'm pretty convinced, and numbers-wise, there's life out there. But the challenge is finding it. And so we've been looking through our solar system. If we go through the lectures, I know there was the Beagle 2 lander that landed on the moon. And Monica Grady was talking about that in one of the Christmas lectures previously.
Yeah.
And we've been looking for life on Mars. Now we're looking for life on some of these moons of Jupiter and Saturn. And now we're finding these exoplanets. We're trying to look for life out there. And that's one of the themes for the Christmas lecture this year, life, and where to look for it and where we might find it. And there was a recent result coming from Cambridge University where they thought that they might have detected a molecule which on Earth can only be generated by life, by bacteria. And so yes, now we're actually getting the tentative, the slight taste of, I know, is there life out there? And we're using again spectroscopy to pick up these molecules in atmospheres which are sort of light years away from us. And so yes, but the problem is it's sort of a tentative taste. It's like a whisper of a flavour, but it's getting that definitive evidence. Yes, there's life. But there are plans afoot to send probes into space, probes travelling at vast speeds, flying past sort of exoplanets, taking images of them, because that would be sort of a nice confirmation. When we do the molecular way, we get sort of a flavour. Oh yes, there are these molecules. They could be a sign of life. But is it definitive? There's something else generating those molecules, a natural process. So it's the jury's out, but it's exciting times because I feel we are on the cusp of and maybe the aliens will just come and look, hi, we're here. We've been next door for a while.
Get in touch.
See, I'm reckoning in the next 200 years, I'm hoping that we will definitely have, that sort of that definitive yes.
Yeah.
And people will be looking at my Christmas section and saying, oh, she was
so
outdated.
I know,
yes. How primitive was that?
But I guess that's kind of the beauty of science, is that's how much we learn.
Yes.
And how far it goes. Do you have a favourite kind of piece of space research that you've heard recently that has really made you excited, that's either in your field or maybe something completely different that you don't really work in, but you just thought, oh, that sounds really cool?
So actually this detection of life, I think it's a potential life. I need to qualify, yes. I find that very exciting. I think because it goes to the fundamental question, are we alone in the universe? And it's something that we're... even before we had a better understanding of what the universe was, it's something that is a fundamental question, one of those deep philosophical questions. And it's quite interesting to see how we'd respond if we found there was life, if we weren't alone. And it's quite interesting because I think research indicates that people don't want to be alone. They want something else to be out there. And in my perspective, I feel that if we did discover we weren't alone, we might actually unify a little better. On Earth, I think we're still quite fractured. We find our differences and lean into those rather than the things we have in common. And I think if we did detect aliens, we'd see that, no, we are very, very similar and we should work together more and sort of unite more, not against anyone, but I think it would show our humanity and what links us together. So I'm looking forward to the alien detection.
Yeah, I think it's unlikely that we discover life and they look like humans, but a little bit different. I think they're probably going to look quite different. So it definitely will be a nice mutual bonding experience for humans.
Yes, but I do love exploring that there's a whole area called astrobiology, and that's something that gets me very excited, because as we detect more of these exoplanets, we thought the planets of our solar system, once again being quite conceited, the standard planets that we would find out there, but now we're finding sort of hot Jupiters, so planets the size of Jupiter, gas giants, but very close to their local star, and it's trying to find the implications of that. But astrobiology tries to work out what sort of life you might find on these planets. And that is sort of creativity. So science and creativity married in a beautiful way, trying to work out what could live on these planets. And so, yes, I love the idea of, aliens. And in lots of sort of science fiction, sort of TV and films, the aliens look very much like us, but they're slightly green or have got an extra
creepy.
eye. I know.
Yeah.
I think it's easier to do it for production.
Yeah, probably.
But I love the idea of really alien aliens.
I remember seeing a graphic that was, someone had done a diagram of if humans evolved from owls. Ooh. And it was just kind of owl people. It was terrifying. It was really horrible. But
imagine that'd be a bit...
Yeah, really unsettling. And I'm not the biggest fan of owls anyway, so it just didn't sit well with me.
Start,
did not sit well with me. But it's interesting to think about, because it probably won't even be the same kind of course of action on another planet if it's a completely different environment.
Yes,
so
the evolution and everything.
Yeah, it's hard for us to even fathom what that might look like, but that's kind of exciting as well, because we don't have a clue.
Yes, and I think it's the anthropology. I think we don't see ourselves, but I think if we almost see ourselves, it's like you were saying, the reflection of the universe in ourselves. I think if we see ourselves, we're getting deep and philosophical here, but see ourselves in others' eyes, I think we'd get a different perspective. But space does that. One of my favourite images of all time is Earthrise, taken by the Apollo 8 mission as they were flying over the moon's surface. So they didn't land on the moon, but they grabbed an image of planet Earth from the moon, and it transformed our feelings towards Earth. Suddenly Earth was small and vulnerable and in need of looking after, and people think things like that inspired the environmental movement. So I think that different perspective can really change things.
There are endless successes in the history of space exploration and astronomy, but it's also a field where the failures are maybe more apparent because there are so many eyes on it as a field. And even with things like Hubble and the mirror being the wrong shape, we don't achieve these successes without a lot of failures along the way, and it's a really integral part of the scientific process, which I think is important to highlight, that not everything goes right all the time, because we wouldn't learn anything if it did. So do you have some kind of favourite failures that you've encountered throughout your career?
Yes. Well, actually, and I think it's a really important point to make. And the thing is, because in the news and in everything else, it's success here and success there, but it doesn't look at sort of I like to see it as a branched path. We do an experiment, that doesn't work, so we try a different way. It shows us the right direction to go, but each of the branches which doesn't give us the result we expect gives us more information. And so, my career has been sort of littered with things like that. And it's funny because personally and sort of professionally as well. And so I'll think of a few examples. Going sort of back to my A-levels, I didn't quite get the results I wanted, and it felt devastating at the time. But it sort of took me on a slightly different path, and one that I really appreciate looking back today. Looking at sort of projects I've worked on. I was working on one project, and it's a satellite called Aeolus, measuring wind speed in the Earth's atmosphere. And the thing is, when you put something in space, you need to test it so that it will survive the launch. The launch is violent and horrible. And you need to know that once it's out there and in sort of a low Earth orbit, it's in a microgravity environment, so it's always falling towards the Earth. And that's fine, but getting it there is a challenge. And we were working on this project, making these tiny cameras that were going to analyse light coming reflected off particles that are under the influence of the wind. And we did the vibration tests, and the heat pipe failed. So the heat pipe was conducting the heat away from the sensor to keep it cool. It just failed. And so we sort of had to go through a number of iterations, came up with a better design, used better purity of copper. But all of these things were a learning curve. So we made heat pipes better in that respect. And then it's sort of on the human scale, we are littered with. And actually, that's one of my biggest things. My biggest fears for the future. I think space is fantastic, but I want us to learn the lessons of the past and not just keep on making the same mistakes. And so we talk about going to Mars and Moon, Mars and beyond. So I have that tattooed on my forearm.
Just to remember.
I know, just my trajectory. So I'm here, Moon, Mars,
next step,
beyond. Okay. And so, my fear is that as we do look out and talk about maybe colonizing Mars, of course, we need to make sure that there's no life on Mars before we ever dream of doing anything like that. But we could, in the future, terraform Mars, make Mars more Earth-like. But the thing is, it really feels as if we've had a wild party here on Earth, we've trashed the place, and now we're looking to go to the next place. So again, let's learn the lessons, because otherwise we just keep on making the same mistakes.
You mentioned earlier you like to encourage children and people that you speak to have a big, crazy dream. And I'm sure these inevitably change over time. So you've had multiple throughout different stages of your life, I'm sure. But what is your current big, crazy dream, if you have one?
Yeah, well, I think sophisticated people, their crazy dreams evolve.
Mm-hmm.
See, mine, no.
Still the same. That's fine.
But
you know what you want.
The route to getting there has changed,
mm-hmm.
and the sort of adjuncts along the way. But from the get-go, I wanted to get out into space, and that still stands. I think there is a magic and a transformative power of seeing our planet from space. And so, the moon, Mars, beyond is still there.
Yeah.
But it is trying to make space accessible for everybody, but make space a place where we can help humanity. And most of the work I've done as a space scientist has been doing that, looking at climate change, building satellites that sort of look at how plants photosynthesize so we can sort of feed the world better. Space can play such a vital role in that. But there were organisations I work with, like the International Rescue Committee. They try and help people in the worst affected areas of the world. And unfortunately, it can be due to climate change. It could be due to war. So many different things are devastating people's lives. And space can play a part in that as well. When a disaster hits, those images from space can really help people. They work out, what roads are blocked off, where the largest sort of conurbations of people are in refugee camps, things like that. And so I think it is utilising space effectively for everybody. And so that is a challenge for the future. So all these things along the way of getting out there into space.
I think it's good to know that dream hasn't changed. It's a good dream. So I wanted to finish with obviously a Christmas lectures themed question. But when this episode goes out, it will just be a few weeks until they're on TV, which is very exciting. Weird to think about November now.
I know.
But to get people to watch them, what would be your one kind of pull in for people?
My hook.
Yeah, what would be your hook?
Yes.
What would your sales pitch? What would it be?
I'll say, my sales pitch will be, we live on a fantastic, glorious planet. But on this planet, we're looking out at the heavens. And in this Christmas lecture, we are going to travel out there, understand it better, and search for life out there. And so if you have ever asked the question, are we alone in the universe? Come and watch. We'll say what the state of the art experiments are to try and answer that question. It is a fundamental question we have been asking since we could contemplate the universe. I don't know if we can supply answers, but we are going to look and see how far we've come, especially in the last 200 years.
Well, I'm sold, so I'll be watching them. Make sure you tune in. But Maggie, thank you so much for coming on the podcast.
It's been lovely speaking to you. Thank you so much. Brilliant questions.
Thank you. That's it for this episode. Thanks so much for tuning in. And make sure to tune in to the Christmas lectures with Maggie this December between Christmas and New Year on BBC4.